Hello and welcome to the first talk in this track. We have Chris here from Germany, and he will talk about what is new in Angular and what is the changes that are made and how you can enhance your productivity and your performance there. Thank you for being here.
Yeah, thank you for joining. Great to see so many faces this early on this Friday here. Yeah, I want to talk about the new Angular. So I specifically decided to not put the version number in there because doing conferences in May is always a little bit dangerous if you're doing Angular development, because just like 2 days ago, Angular 18 was released, so the new major version. And as you might know, Angular releases 2 major versions every year, and so just 2 days ago, this new version, Angular 18, has landed. So what I want to tell you today is basically valid for both Angular 17, and I also try to add some of the new features that are introduced by Angular 18. Alright, so my name is Chris. I'm a Google developer expert, and I'm pretty much in touch with the Angular team. So yeah, that's basically what brings me here. With Angular 17, or maybe 16, it's hard to say, the Angular Renaissance was started, so to say. This is the term introduced by the Angular team itself. And what it basically means is the rebirth of Angular, and I think it's pretty much true. Also with Angular 17, the Angular team introduced a new logo that you can see here behind me. And I think it just makes sense because there's so many things changing in the framework that they also decided to just change the logo. Also, with Angular version 18, again, released 2 days ago, there's a new Angular website. Angular.io was the old website, and Angular.dev is the new one. It's a little bit fancier, documentation was updated, and there's interactive tutorials that you can use. Yeah, it all started with around Angular 16, and here are the talking points for my talk. The first point is signals and signal-based inputs or components. So the reactivity story of the framework is changing. It was or is still currently based on RxJS, but RxJS is complicated, so we want to make it easier for beginners, so we need something new, and that is a signal. Also, we want to change the change detection mechanism in Angular because it was a little bit faulty sometimes. Then there are standalone components and modules. This improves the architecture of Angular applications by making ng modules redundant. Then there's a new built-in control flow and the so-called deferrable views. This is a new version of ngIf and ng4, for example, which is faster than the previous versions of it. And then there's SSR and hydration, and it also, in the same step, so to say, introduces new build tools. Right now, or before this effort, Angular was based on Webpack, which is a little bit aged by now, so we now want to make the switch to more modern build tools. And so as you can see here, all of these points on the slide, they have a common goal, and that is that we want to streamline the APIs. We want to make it easier for beginners to learn Angular. The second one is we want to modernize APIs, again, make them simpler and adapt to recent developments on the web, and we want to improve performance. That's the idea of all of those things that change in Angular. Yeah, but if you are familiar with the history of Angular development, this does not mean, so to say, that everything is lost, which it did right now, right? So everything continues to run this time, but still the shape of Angular application will change significantly. When I go to customers, right, and I open their Angular code base, you can basically tell by the eye whether this is like an Angular 4 workspace or whether it's an Angular 18 workspace. It's visually visible, so to say, in the code. Again, no worries, all of the new features are backwards compatible and interoperable, so we don't have another AngularJS scenario that we had like 10 years ago or so, so everything will continue to run, at least for now. But still, I would recommend you to migrate your applications as soon as possible, and in the session we want to talk about why, when, and how you can do that for each of the 4 talking points. And I want to start with the first one, and that is Angular signals. So what is a signal? As I've said, signals are a new version of, or a new concept for reactivity in Angular applications and beyond. In fact, YouTube is now based on Angular signals, which is quite interesting, I think. RxJS is super complicated. If you want to learn Angular, then you also have to learn this other separate framework. So basically the Angular team decided to give us an easier version of it, so to say. So essentially, a signal is a reactive primitive, right? So it's a wrapper around a value, and that can notify interested consumers whenever that value changes. It's basically like a behavior subject, if you're familiar with RxJS. But this entire concept is a lot simpler than RxJS because we don't have these tons of operators, right? But only like a few key APIs that I want to show you on the next slide. And signals form the basis for a new, more effective change detection system in Angular that could eventually replace Zone.js, which would be a performance improvement, and I want to talk about that in a bit. So let's have a look at the signals API. So to create a new signal, we will simply call the signal method. That is also interesting because Angular now takes this functional path again, right? So it was very object-oriented with classes and so on, but now basically it gets a lot more functional, like generally. So if you want to create a new signal, you can simply say signal and then pass in the value that it should wrap. And then whenever the value changes, you call the .set method on that signal. Then you can have dependencies on this signal. For example, here in this case, we have a count signal at the top, and we want to have a computed signal that just gives us the double amount of the count signal from the top. And so you can simply use the computed function, call the signal, that means read the value from the signal, and then multiply it by 2. And so, that's a nice thing, you can be sure that double count will always contain the count multiplied by 2. Always synchronously available and always true, so to say. And if you want to respond to a change of a signal, then you can use the effect method and just again within the callback of this effect method just access the signal, and then you will also get the current value, and this callback will be invoked whenever the value inside changes. That's the basic idea. And that's more or less the API surface that you should know. So setting, reading, computed signals and effects. As I've said, there's always like a backwards compatibility and interoperability story. So of course we still want to be compatible with RxJS and integrate with RxJS. And therefore there is the possibility to convert an RxJS observable into a signal using the toSignal method. If you use RxJS, you are familiar that it must not necessarily have an initial value, so you have to pass it here, where that's not the case. And you can also do it the other way around, so basically convert a signal to an observable in cases where you have an RxJS chain and you want to do something with it. If you've used the take until destroyed operator in RxJS, interestingly, that also comes from this signals and RxJS interop package. And that's basically the API surface. As you can see, it's pretty simple, and that's the idea of this Angular Renaissance effort, right? So to make things much simpler than they were before. And it's the same for the for the change detection mechanism. So up until now, Angular uses a library called Zone.js. It's authored by the Angular team itself, and the functionality of this library is displayed here. So when your Angular application launches, Zone.js creates the so-called ng-zone, and this ng-zone basically listens to whatever change could happen inside your browser tab, so to say. So it attaches to all events, it attaches to calls to set timeout or set interval, and it also patches certain APIs to get notified whenever something changes. And then basically when it notifies or when it notices such a change, it will check your entire application and re-evaluate the bindings in the app. That's like the very basic form of it. It of course can be optimized, but that's like the default behavior. And you can see that this is pretty bad, right, for performance, because maybe we check things too often. Maybe you click, like, let's say 10 times within the browser tab, but no binding changes, right? So we are checking the Angular application completely unnecessarily. And also, Zone.js has some flaws because it needs to patch those APIs. If I use an API that is not patched, for example, WebSockets, then the change detection will not run. So you can end up in a horrible state where the view is out of sync with the actual data model. So that's why we want to get rid of Zone.js and throw it away. Instead, we want to rely on signals. Okay, my clicker has died. Too bad. Okay, now it's back. Instead, we want to rely on signals. So now we've learned it's this wrapper around a value, right? And so now whenever the signal changes, whenever it notices that there has been a change of the data value itself, then it emits a change. And in the future, this could mean that we can simply update the one and only binding, so to say, in the view that is actually affected by the change. Right? So instead of checking the entire application tree over and over again, we can directly identify in the HTML what has changed and only reevaluate this binding. That's the idea, and that's the path that we want to take. All right, that are signals more or less. Now let's see how we can use them. So it's pretty simple. So you can simply put them in your component class, so to say. But the thing is, now we have also like inputs and outputs, right? So what we typically did to receive values from the outside was to just add this add_input decorator, and then basically we could read values that came in from the outside, and we would bind to that value, as you can see on the left hand side here, like that. As you can see on the right hand side, signals always need to be called to read their value. So here we add the two parentheses, right, to get hold of that value. And now the API changes, and here's how. On the right hand side, you can now see that we simply call the input method. So it's calling a method again, right, just as for the signal. And that's it, so to say. And that's pretty cool. Because it has some advantages. Let's have a look at that. This is a common scenario where you have like a required input. But the problem is that you cannot specify like a default value for this required input, right? And so that's why we typically need to use this exclamation mark to tell TypeScript everything is fine, there will be a value at runtime. And that's not so nice, right? Using exclamation marks. And so that's why, with the help of this new method, we can simply call the .required method on it, and now this value 2 is filled, right? So now we get a signal, it will always be there, and Angular will make sure that the value projected will be right. These are signal-based components introduced with Angular 17.1. And from there it was improved. So for example, let's say we have this two-way binding, right? ng-model, for example, that works by using an input and an output. And now there's also a new API for that. And that is called model. So you can simply say equals model. In that case, it's also required. And then you will get a signal for this two-way binding, right, on the outside. And with Angular 17.3, the same mechanism was introduced for the output decorator. So instead of writing this, you can now write this one here, so simply call the output function. And here you can also see that the API is simplified, right? Because we only have one line of code and we don't need to use an event emitter and stuff. That's all handled for us by the framework. With Angular 17.2, also the old view queries were not really replaced, but there's new versions for it. So instead of using decorators with the same problem, which is that we have to use the exclamation mark, the non-null assertion operator, we can now simply call the viewChild, viewChildren, ContentChild, and ContentChildren methods to get hold of the instances of the particular components that you want to get access to. And that is super cool, and I can only recommend it. Works really great. And as you can see, instead of 8 lines of code, we now simply have 4. With the newest release, again 2 days ago, Angular 18, there's now the possibility to opt out of Zone.js, so that flaky change detection system. Here's the method for that. It's called provide experimental zoneless change detection. You can simply call it in your app config, and then basically Zone.js will be turned off, and you can then rely on the new signals-based mechanism, which is pretty cool. And I will try that out in in our first customer apps. But be aware, this is experimental, as the method says. Yeah, also the ecosystem has changed. So NGRX, for example, they also offer a signal-based version of their store. It's in the package NGRX Signals, and is a great replacement for the previous component store and the NGRX entity adapter. And they also adopted this new functional approach, so you can still use classes, but you don't have to. You have the option to choose whatever suits your application and your architecture. So let's have a look here. So first of all, maturity. Signals are stable. You can use them. There are only some things that are still in developer preview. That is the effect method, the RxJS interoperability, and all of the new methods that I've shown you, so input, model, output, and so on. So they are still dev preview, also in the latest version. And NGRX Signals, that is also still in developer preview. Yeah, how can you migrate? Why should you do it? Let's start with that. You should definitely migrate to Signals. That's the way forward, right? In Angular, the idea is everything that you bind to the template must be a signal. So from the Angular side, it's a should, but I would recommend you to just do it with Signals. When should you do it? I would write new components based on Signals starting from now, and whenever you have time, I would also just basically adapt the rest of your components that you have in your application. There's no hurry, so RxJS will stay, and the traditional ways will also not go away anytime soon. But yeah, I mean, as always, don't lose time and just do it before you have to switch everything in a certain point in the future. So how can you do it? This can only be done manually, so there is no automated migration available, so you have to revisit all of the components of the templates to do it. There is an idea to provide a migration, but it's not there yet. Maybe GenAI can help. In the end, I guess it'll be a manual effort. That's the first big change. Signals. Reactivity done better, I guess. Then next talking point is standalone components and APIs. Maybe you are familiar with ng modules. That is something that has been introduced basically on the last steps towards Angular 2. So when they created a new version of the Angular framework, they wanted to do it without modules. But then the AngularJS developers came, which knew modules before, and said, oh no, we want to keep our modules. And so basically the Angular team brought it back. Now ng modules die again, so there's an alternative way to do it. What is the problem with modules? Modules are collections of Angular building blocks, so components, directives, pipes, plus services and providers that you can group in a box, let's say. The problem with that is that this pretty quickly gets a little bit messy, right? So you have huge ng modules with tons of dependencies and components and directives and so on. And there's oftentimes a scenario where you build endless loops, right? From the import paths, for example. So that is a big issue and a problem. Also, the Angular team itself has problems with that approach. For example, here you can see a component, right, that uses ng4 and this app tooltip pipe and the app tooltip directive and the my pipe. But the question is, where do these two things come from, right? And the answer is, we don't know. we need to scan the entire code base of your Angular application to identify the module where your component belongs to, and then check whether there are dependencies that you want to use. So that's pretty bad also for the tool implementation, right? So for the Angular CLI, because you can never know where these dependencies are coming from. And so that's why it now all gets streamlined again. You can now opt in to standalone components by saying standalone true. And I expect that in the future you will have to say standalone false and all the others, right? But that's not the case right now. And then in the imports array, you have now to specify all of the dependencies you want to use. And now everything is much simpler because your component explains itself. It specifies from where we get our dependencies that we need to use. And this allows us to build way better application architectures than with this big module chunk that we had before. Everything is still working. Lazy loading will still work as you expect it to, even without modules. You can simply load a component. That's all possible. And yeah, not much of an issue. You can also provide injectables, for example, on a certain route, if that was your concern to use ng modules. So basically for every question that you could have why ng modules were great and why you want to continue to use them, there's basically an answer that you can still migrate to standalone components and standalone APIs. All right. And also there's again an interoperability story. So you can use standalone components and directives and pipes in ng modules by adding them to the imports array of the module. And it's also possible the other way around. So if you want to use a module in a standalone component, this will also work by simply adding the module to the imports array of your component. So all of that is perfectly fine. And just as with signals, we also have an interoperability story here. Now, why do we need this? Why is this great for us? So there's Angular Elements, a way to write web components with Angular. But the problem is that you don't just have to write the component, but also just for the sake of actually nothing, provide this module, right? So we want to make that possible and easier. And this is exactly where standalone API helps us. Due to this simplified API, we can now create web components much easier that can then be used in any context, not only Angular applications. Just be aware that for now we still have this dependency on Zone.js, but we are going to get rid of that as well. So in the future, it's not too far away, we'll also be able to write great web components with the help of Angular. We are not 100% there yet, but the time will come. Yeah. It's even like visible in StackBlitz, for example. If you use StackBlitz sometimes to demo something or to try something out, then you may have noticed that the application that you see on StackBlitz on the right hand side is actually a single file, right? So there's only there's only the main TS, and this single file includes the component, and then in the end only calls bootstrap application. Bootstrap application is a new API. It's then called a standalone API, and that means that we don't need to provide a module as we need to do it as we had needed to do it before, but we can simply pass in a component. In that case, it's app, and everything will work. So instead of adding this extra layer, so to say, we can directly pass in a component to the Bootstrap application call, and it will simply run. This single file is all it takes to actually run the Angular app on the right hand side. Big improvement. This also means that the folder structure of our Angular application changes. So left is the old structure and right is the new structure. So in standalone apps, the main TS remains, but there's no routing module anymore. Now the file is simply called app.routes, and there is no app module anymore. Now the file is simply called app.config.ts. So basically the modules are all thrown out. Of course, we still need the routes and so on, and the basic configuration, and they are still there, but it looks a little bit different and without the bloat of the modules around it. So let's have a quick look. Left is the old API that required a module. I mean, it's called Bootstrap module. Right is the new way. So we simply say Bootstrap application, import the component, and call Bootstrap application. So again, also I think simpler because there's also not the second method here. Then if you, for the providers, for example, for the config, left the old way, we had this app module where we added the imports, and the new approach is to have a configuration object, so essentially the thing that wasn't a decorator, right? And here you would add the providers with more function calls that we've seen today already. All right, and there's a possibility, again, interoperability to load the old modules as well. Okay, yeah, maybe let's skip this. Okay, now talking about this block. So standalone components and APIs are also fully stable. I would use them from now. Also, if you create a new Angular app, they are used anyway. They improve the developer experience and prepare your code base for upcoming Angular features. They even started to deprecate like the HTTP client module, right? Not the HTTP client, but the module as a way of using this thing. So yeah, it future-proofs your application. New projects should only be started with standalone APIs. New components should only be added as standalone components. And I would also here in that case basically migrate them as soon as possible, yeah, while making sure that the new parts are always standalone. Be aware that some of the ng-add or ng-update integrations may not work with standalone workspaces if they are super old, but that may also be an indication that it's not a great idea to continue to use them. How can you do it? In this case, there is a migration available that partly automates this process. Manual changes will still be required. We migrated a smaller project in a day, you could say. The problem is that there's no functional difference. So you really have to convince your boss and say, hey, this is for future-proofing our application because it will behave the same afterwards. There's also no performance improvement this time. Be aware that changes to the project setup may lead to the migration to break this automated migration. It may fail doing the replacements in unit tests, and it does not introduce this new folder structure that I've shown you. So not the new app.config.ts files and so on. It leaves them untouched. And this is the migration that you can run. ng-generate add angular / call standalone, and it will then run you through the steps to migrate your Angular app. Cool. Next talking point is the new built-in control flow and deferrable views. On the left-hand side, the old version, so there's this like asterisk ngif, and it's a great example actually, right? Because it shows how convoluted that syntax is and how ugly, right? So if we have this else case where you want to show something different, then we need this ng container around the ng if, and then we need an ng template. Why actually, right? Have this template reference and then reference that in the else part of the ng if. Explain that to a beginner. It's not easy, right? And so that's why there's this new control flow syntax that has been introduced. It's now called add if. Right, and there you can place the content, and there's an add else branch where you can directly place the content into. So again, same thing, much simpler, right, and definitely something that you want to use, and better for beginners. All right, so why do we want to do this? In this time, there's even a performance improvement because this new control flow is directly built into the renderer of Angular. So there's no need to import something, for example, a common module or ngif, as we did it before. We don't need these dummy DOM elements any longer, such as ng container. We get rid of this Angular-specific structural directive syntax that no one else uses. And for example, in the case of ng4, we get a performance improvement up to 90% because we no longer rely on Zone.js. I mean, you can see the story, right? To re-render when something changes. And again, we improve the developer experience when we deal with very common scenarios. Be aware that the built-in control flow is not extensible, so you cannot extend it and create your own add whatever. That's not possible because it's a built-in feature of the Angular compiler. Some more examples. This is ng-switch, also not easy to write because we have this attribute at the top and then the switch case structural directives. It's all much easier now, right? It's just an add switch with a condition and case and the default at the bottom, just as we would write code, I guess. And for is also nicer now. Left the old version. On the right hand side there's the new version. It's add for in this case. They even added an add empty block for the case where you have 0 items, which was also a little bit complex to implement before. Yeah, so also in that case, much better than it was before. Yeah, migration strategy. Also, the built-in control flow is fully stable with version 18, actually. That was released 2 days ago. So I would use that thing now. It improves the developer experience and improves performance. So use that thing now, starting from now, and migrate the rest of your code base as soon as possible. All right. Be aware that your IDE must support this, but all recent versions of WebStorm, VS Code, and Prettier support it. And be aware that the syntax also does not match the HTML standard. So if you use older IDE versions or some tooling that does not know the syntax, there may be problems. But all of the other well-known tools, including Prettier and so on, yeah, support it. How can you do it? There's a migration to automatically migrate to the new built-in control flow, where you can pass in the target path, so you can also just migrate a part of your app. It also formats the files afterwards and removes the common module or structural directive import from the component class. Still, you will pretty likely have to perform some manual changes and check what you did. Effort for a mid-sized project was less than an hour. And again, no functional change, so you need to convince your boss. Okay, how can you do it? Oh, sorry, let me just show that slide before. This is the migration that you can run. This time ng-generate at angular/control flow, just as with standalone. But be aware that for will track the count variable by default, which is not the best or the optimal way. So if you have an ID, you want to track that. The new built-in control flow does not support some very rarely used features of the old structural directive syntax, which is renaming a collection or giving multiple aliases to an ngIf. I think nobody ever used this. If you did, you have to change that. And the template reformatting, unfortunately, does not use Prettier. So you have to format it again, at least in my case, where we use Prettier in a project. Another nice case where we also see that new features of Angular built on top of these new things and approaches is deferrable views. That is a pretty cool block, and that's the result of a cooperation between the Wiz framework team at Google and the Angular team. So for example, YouTube and Google Maps and so on, they use Wiz, like a Google internal framework, which is heavily optimized for server-side rendering, for example. And Angular is very optimized for developer experience. And in the future, those two frameworks will merge and form one framework. And at defer, the defer block that we see now is one product of this collaboration. So deferrable views take lazy loading a step further. It was possible on a route basis, and now brings it even to the template level, to the view level. You can specify a fragment of your application where you want to lazy load things. And this is exactly what this defer block does. And with the help of that, you can basically offload large chunks of your app or rarely used chunks and only load them when they are actually visible, for example. Everything provided by template magic, so you don't have to care about anything, right? All handled by the framework for you, and it uses this new defer block. And also here we have some nice helpers like add placeholder that show while the content is being loaded, or add error when the content cannot be loaded, for example, because you're offline or the server has crashed. It's all implemented and supported out of the box. And that's a nice example for something that is only available using the new syntax. So there's no structural directive equivalent of this. Another reason why you want to migrate to the new approaches as fast as possible. So this is again the code for that. Add defer, then the trigger when you would like to load that stuff. Again, possibility to show placeholder while it's loading, and the add error while it is, that is shown when there's an exception. There's also an add loading block, I think. Yeah. All right, and last talking point for today is SSR and the new build tooling. Again, why do we want to do this? In this case, it's a performance improvement again. Server-side rendering would pre-render the application on the server, which significantly improves the load time, because we don't have to launch Angular on the client to show the DOM nodes that are created by Angular, but we can directly show what we get from the server as HTML. We'll see it on the next slide. Then there's pre-rendering or static site generation. Let's say you have static routes. Then we can pre-render them at compile time, so that we don't even have to compile them during runtime, right? Because they won't change. This is what static site generation does. And this improves server response time, because not even Angular has to run on the server, right? It can be done on compile time. And then there's hydration, which allows the client-side Angular to just attach on the existing DOM nodes that we receive from the server, and this improves the client-side load time again. Just a little side note, because that's super new, announced at Google I/O, there will also be the possibility of partial hydration, which means that we can render the content of a defer block, so again, on one view, during runtime on the server, and then reattach on that thing on the client. Here, no SSR, and on the right-hand side, version with SSR, so the server pre-renders the HTML that we want to show. And that is basically displayed. Big performance improvement. There are some caveats which we'll talk about next, or in a bit. In Angular 17, SSR is now fully integrated with Angular. It's super easy to set up. All you need to do is call ng-new -SSR, so it's no longer a separate library. It's built into the framework itself. If you've used SSR before, you need to switch to a new application, the so-called application builder, and update your config to use it. Now let's talk about the caveats. Setting up SSR is hard if you use authentication, and SSG may be impossible at all, because if data is dependent on the rights that you have, for example, then it's gonna be complicated. No Zone.js, which is the goal of Angular, is not supported right now, or a custom Zone.js implementation. Angular internationalization is, I think it's even supported by 18, but I'm not sure. It was not supported in 17. When you use service worker, then SSR is only used on the first visit. All components that if you want to use hydration, must support it. And if you use libraries that use DOM manipulation directly, for example D3 or whatever, then this will also break hydration. So you see, SSR sounds nice, but the effort may be super high if you really want to do it. So be aware of that. The new server-side rendering is based on new build tools in Angular. So instead of Webpack, we now want to use ESBuild and Vite. Why do you want to do it? Because it's much faster. Webpack is here at the bottom, right? So here's a code base. Webpack takes 40 seconds. In ESBuild, it's less than 1. Maybe that's a little bit better. That's an actual Angular code base. Blue bar is Webpack. The red bar is the new ESBuild and Vite based builder. So we get significantly improved build times. So this time it's developer experience again. For initial as well as incremental builds, we get compatibility with native ES modules and the modern ecosystem, and you get HMR for styles, which is again a performance improvement. So, all new apps from Angular 17 will automatically use these new build tools. Why do you want to do it? Faster build times. When do you want to do it? Do it now if you can, right? So Webpack is still stable. Older apps are not migrated automatically. With Angular 18, you are asked if you want to migrate. And yeah, you should just do it, use the new build tools. And if you run into any problems, then you can try to use browser ES build, a compatibility builder. And if that doesn't work, then switch back to the standard builder. All right, I will just do my summary slide if it's if it's fine. Perfect. So what have we seen? The Angular Renaissance is real, right? So it's so much ongoing in the framework. That's a good message. There are notable advancements. Everything is backwards compatible. We get performance improvements on build, runtime, and compile time. So keep your users and developers happy. Keep your code base up to date. And yeah, avoid technical debt and migrate now. Thank you for listening.
Thank you very much. We have a couple of questions. The first question is, when using ng-zone, does the whole application get re-evaluated, not just the component and the child component?
Indeed not. So it re-evaluates the entire application tree, unless you use, let's say, the on-push change detection strategy. But the default behavior is we re-evaluate everything.
Okay, the next question is, should you just wrap signals in a getter and setter for its set function to mimic the old way?
I don't know why. I would simply use the new signal syntax. I don't see any gain in that. It may be possible, but why?
The next question is, what's your takeaway on using effect? Angular documentation at least previously discouraged from using it if possible.
It's fine to use. It's maybe in the documentation because it's not like fully stable yet, and of course there are also some caveats. We are using it in production, and there's no big issue or bigger problem that I have noticed.
And the last question is, do we need any new tool or technique for debugging and monitoring applications using the new signal-based change detection?
Depends on what you used before. So the Angular dev tools are being improved to explicitly support stuff like that. So for example, the behavior of signals. So what emitted something, right, and what was the chain that led to a certain change. So that is built into the Angular dev tools. If you've used them before and you want to update to the latest version, I'm not sure if it's in there yet, but it will definitely come.
All right, that's it. Thanks again, Chris. Thanks for all the questions from the audience, and thanks for being here, and looking forward to see you again.
Yeah, thanks for joining.